Good afternoon, class. Thank you. You can sit down. Okay. In the previous lesson, we left 4 questions to be answered and explained by 2 groups who didn't have their turn. Okay, I think the questions were letters F, E and F, if I'm correct. And letter F was 2 1/4 raised to the power of 3. And letters M and N. So the group that was answering questions E and F, please come to the front and see if you can explain your 2 questions quickly, and then we'll have the group that was working on M and N. Square root of 2 1/4 cube. Yeah, I didn't say it properly.
First we have to change 64 to the power of -1/3 into a positive form. So we change it into a mixed fraction, which is 1/64 to the power of 1/3. And we have to find the square root of first we have to find the cube root of 64, which is 4. So we change it to 1/4 to the power of 1/2. So that means we find the square root of 1/4, which is a half.
Good.
(27 on 8) or 3 and 3 on 8.
Thank you. The next group, those who answered letters M and N.
4 raised to the power of 1 over 6 times 8 raised to the power of 1 over 3 is the same as finding the 6th root of 64, then multiplying it by the cube root of 8. So the 6th root of 64 is 2, and the cube root of 8 is 2. So 2 times 2 equals 4.
Good.
Firstly, I multiply the indices. 2 raised to the power of negative 1 over 3 with the 6th power. I've got from this I've got 2 raised to the power of negative 2. On this side, square the 2, I got 4. Find the root of that, and I've got 2, and I cube it, and I got 8.
To cube is 8.
2 to the power of negative 2, which is 1 over 4, in its positive form. Multiply it with 8, I got 8 over 4. I simplify that, and I've got 2.
Okay. Well done, thank you. All right, today's lesson will be based on scientific notation. So if you can have a look at the board. All right, scientific notation or standard index form, sometimes standard form is also used. So if you see scientific notation or standard index form or standard form, it means the same thing. Okay, it says this is a device which is used to record very large numbers or very small numbers. It's used mainly by scientists or people who do research. Okay, example, write the following in scientific notation. Okay, the rule is there must always be 1 digit. Okay, not 2 digits, 1 digit before the decimal point. So for this number, 0.00316, the decimal point must go after 3 because that's it's a digit that must be greater than 0. Okay, not 0. So the decimal point goes here. All right, 3.16 times 10 to the power of negative 3. It's negative 3 because you have to get back to this number. From 3.16, if the decimal point is here, you'll have to go back 1, 2, 3 places to the left to get back to this number. That's why it's raised to the power of negative 3. If you move to the right, then it will be raised to a positive power. Number 2, 94,700 to scientific notation is 9.47 times 3 cubed, because if the decimal point is here, then you're going to go, or it should be 4. 1, 2, 3, 4. What a silly mistake. Okay, it should be 4 and not 3. Okay, multiplying and dividing, scientific notation or numbers in scientific notation. Okay, I've got 1.2 times 10 to the power of 4 divided by 6 times 10 to the power of 1. What you do is you divide the numbers first. So 1.2 divided by 6, which is 0.2. And note I've got a mistake here too. What you do then is, because it's division, you subtract the indices. I actually had multiplication and then I removed it and forgot to remove the power of 5. So it's 4 take away 1, which is, this one should be 3. So 0.2 times 10 to the power of 3. Note, the rule says there must always be one digit before the decimal point, and that digit must be a number greater than 0 and not 0. So if you can have a look at this, 0.2 times 10 to the power of 3, although it's the correct answer, it doesn't follow the rule. So what I did then is I rewrote this 0.2 here as 2.0 times 10 to the power of negative 1, because I will have to move back to come to this number. Okay, then this one should be 3 because it comes from here. So that's 3. And then 3 minus 1 should be 2. Okay, so this one should be 2. So the answer is 2.0 times 10 to the power of 2. Okay, if you're multiplying 4.2 times 10 to the power of negative 2 times 3.0 times 10 to the power of negative 1. Like dividing, you have to multiply the numbers. 4.2 times 3 will give us 12.6. Is that correct? Okay. Then instead of subtracting the indices, we add. Minus 2 plus minus 1 is negative 3. So it's 12.6 times 10 to the power of negative 3. And then again like this, this 12 is 2 digits before the decimal point. It can't be 2 digits. It has to be 1. So what I did here again, I rewrote this 12.6 as 1.26 times 10 to the power of 1. Because from here I'll move 1 decimal point, 1 place to the right. So 10 to the power of 1. And then times 10 to the power of negative 3 will give us 1.26 times 10 to the power of negative 2. Clear? Okay, now adding and subtracting. If I have 9.1 times 10 to the power of 1 plus 3.1 times 10 to the power of negative 2, the rule is you have to write the numbers in full before you add or subtract, and then later rewrite it in scientific notation. So 9.1 times 10 to the power of 1 is 91. 3.1 times 10 to the power of negative 2 is 0.031. Clear? And then that becomes 91.031. And then I rewrote this number as 9.1031 times 10 to the power of 1, because you have to move from here 1 place to get this number. Okay, next one is subtraction. The same rule applies. Write the numbers in full. 3.2 times 10 to the power of negative 2 is 0.32. Take away 1.02 times 10 to the power of negative 2 is 0.0102. And then I subtracted. Just check my answer here using your calculator. See if it's correct, because I didn't use the calculator. Is it 0.3098? 0.32 minus 0.0102, is that equal to this? Yes. Okay. Then in scientific notation, it will be 1 digit before the decimal point. 3.098 times 10 to the power of negative 1, because I'll have to go from here back to give me this number. All right, next. Some word problems that you can answer using scientific notation. The first one, if E is equal to KT, and E is equal to 5.26 times 10 to the power of negative 13 when T is 800. Find K in scientific notation. So I start with the formula E equals KT. I substituted 5.26 times 10 to the power of negative 13. That's E. Then I substituted T. Instead of writing 800, I wrote it as 8 times 10 to the power of 2. And to get K, I divide 8 times 10 to the power of 2 on both sides. So I divided. And then hopefully this is correct. 2.6575 times 10 to the power of negative 15. Negative 13 minus 2 will give me negative 15. This answer you get when you divide 5.26 by 8. Okay, hopefully it's correct. And then in proper scientific notation, I rewrote this number 0.6575 as 6.575 times 10 to the power of negative 1 multiplied by 10 to the power of negative 15 gives me 6.575 times 10 to the power of negative 16. Okay, instead of me giving you the answer to this question, I'll give you the values on the board and see if you can work it out. Okay, it says the kinetic energy of a body of a mass, m kilograms, and velocity v meters per second is given by this formula. Calculate in standard form. Okay, the kinetic energy okay, if okay, I'll give you the value for V. Okay, V is 2 times 10 to the power of 2, and M is equal to 3 times 10 to the power of 4. Quickly find the kinetic energy using the formula. not v squared. So you have to square the value for v. V squared, so square the value for v. Finished? Could be right here. All right, is there anyone willing to give us their answer? Patrick. Mike is there.
6 times 10 to the power of 8.
6 times 10 to the power of 8. You all got 6 times 10 to the power of 8? Yes? Okay. All right, if m is equal to 3 times 10 to the power of 4 and v is equal to that, note you have to square v. So it's half m v squared. And 2 times 10 squared is 4 times 10 to the power of 4, 6 times 10 to the power of 8. Okay, on your worksheet, the exercise on scientific notation. Question 1 first. Okay, to do now, I'm just going to give you a few of those and then you can do the rest for homework. You're going to do question 1 and 2. Question 1, the following: A, C, E, G, I, and K. Every second letter beginning with A. A, C, E, G, I on the monitor. That means you're going to skip two letter H there. So G, I, and what did I say? G, I, and K. So if you can do that before the bell goes. And question 2, you are going to do B, D, F, H, and J. Okay, that's this lesson. I want you to complete those questions quickly. Question 1, you are doing every second letter beginning with A. You're skipping the 2 letter H's. And question 2, you are doing every second letter beginning with B. Okay, quick. All right, letter A. You should have 1.96 times 10 to the power of 1. C, 3.85 times 10 to the power of 2. Okay, letter E. Miriam, can you give us the answer?
5.6 times 10 to the power 1.
Good. G, Dan.
5.9876 times 10 to the power of 4.
Good. Chutaili, I.
6.97 times 10 to the power of negative 2.
Letter K. Hekoi.
5.0 times 10 to the power of negative 1.
Okay, good. Question 2. You have 5 minutes to complete question 2. Finish that. What?
3, 5, 7, 9, 11, 13.
No?
It was 2, 4.
Did you hear what I said? You had to do it according to the questions on the monitor and skip 2 letter H's. Yeah. You did the wrong ones because he typed 2 letter H's on the monitor. You must listen. Now I think it should be all right. B, start from B. B, D, F, H, and J. Yeah. Yeah, it's this one, but you start from this. 2, 4, 6, 8, 10. Make sure you're checking this one. They had you had to do a half and not this one because he typed 2 letter H. I don't know where he got that from. That's why I mentioned you had to do it according to that exercise on the monitor. So I said skip both H's and do the next one. I think he had 0.5. He had 0.5 this one. Oh, he had that, but then I wanted you to do the other one, 0.5. The second one should be correct, should be the same. Okay. It's an easy one, so. Last one is really horrible. 0, 0, 0, 0, 0, 1. All right, most of you have actually completed question 2. All right, Velma, you will have to give us the answer to letter B.
0.00756.
Okay, correct, 0.00756. V, D,
0.0112.
0.
0.0112.
True. Look at it properly. It's 1.2 times 10 to the power of negative 4. Is it negative 4 on your worksheet as well? Okay, so it can't be that. 0. You're moving 4 places to the left from where the decimal point is. So
0.000112.
Okay, 0.00012. Okay, letter F. Solomon.
1.93.
1.93, good. H. George.
99.66.
Correct. And letter I, Andrew.
Uh, 0.00000. 1011.
Okay. There should be 5 zeros after the decimal point and before the number 1 to get the answer correct. All right, then for homework, on your worksheet where it says exercise C, evaluate, leave your answer in standard form. Okay, you are going to do the odd numbers only, and then there are 4 questions at the back. They are word problems. All right, the key word to the pilot teacher is scientific notation. Good afternoon, class. Thank you.